everyone, it's nice to have you guys back on my channel. Today we'll be studying about growth models. There are two types of growth pattern that is observed in a population. First one is exponential growth and second one is logistic growth. Here both the curves are plotted for a population density with respect to time t. Population density is represented by capital N and time is represented by small t. Let us see what happens in case of exponential growth. In case of exponential growth, the resources are unlimited. When resources are unlimited, the population density increases rapidly in very short period of time. But after a certain point, the growth will cease due to environmental resistance. Environmental resistance can be climatic factors or it can be due to seasonal changes. Exponential growth is represented by dn by dt is equal to Rn. Small r is called as intrinsic rate of natural increase. It is nothing but the population's potential to grow to its fullest. Capital N represents population density at time t. Next type of growth that we have is logistic growth. In logistic growth, there is a growth initially which is lower, then it accelerates as there is availability of resources, then reaches a steady state. Thus we obtain a sigmoid curve. It is represented by the formula dn by dt is equal to Rn into k minus n divided by k, where R is intrinsic rate of natural increase, capital N is population density at time t, k is carrying capacity. Now let us know what is carrying capacity. So nature has abundant resources for all of the organisms and to fulfill its needs. But beyond a certain point, it is not possible as the resources are limited in nature. In most of the cases, definitely the resources are limited. This condition is called as carrying capacity. That is the maximum amount of individuals that nature can support in an environment is the carrying capacity. So since this is the type of growth that occurs in most of the populations, we call it as realistic growth in nature. With this, we end our topic, growth models.